All right, okay, so last time we were looking at probability. Remember when there was like a pass or a fail, like or two options. So the probability something is going to happen, and then the probability it's not going to happen. So if you've got that kind of situation, you can use that formula where it's the oh my god, you know what I mean? Well, now this is all connected to it with expectation. Okay, so the expected value from this happening. Now, some expected value questions are really easy, like they're super quick, super straightforward. So we roll a dice 120 times. How many times will we expect it to be a 6? Now, this kind of expectation we've done in younger year groups. How would you find the expected number if you know that you're rolling a dice 120 times and we want to know how many times we get a 6? What would we do? Do you remember? 1 over 6. Multiplied by 120, yes? So we take the probability of the event that we're interested in. So what's the probability of getting a 6? 1 over 6. And if we're doing something 120 times, we multiply those two together. Okay, that's nice and straightforward. So here, if there are n trials in an experiment, an event has a probability of p, then in each of those trials, then we would expect the event to be np. So you just multiply those two together. Nice, easy, straightforward. Oh my god. Now, the expected outcome for the random variable x is the mean result. Okay, so if you've got something a bit more complicated, and it tends to be questions. So here's an example of that first one. Footballer kicks a goal, has got 3/4 of a chance of being successful. In a particular game, there's 12 kicks. How many goals would you expect him to kick? If you multiply those two together, you get nice, easy, straightforward, yes? If something is in any kind of table form or looks kind of like this, then it's getting a little bit more complicated in what goes on. For a start, what do we know about these things here? These probabilities, what do we know? They add to 1, yes. So sometimes it will be a situation where there needs to be 2. Okay, so we know that those numbers have to add to 1. Because these are our different options. We've got 1, 2, 3, 4, 5. And those numbers we know have to add to 1 because they're the probabilities of those events. The expected value here, or the expectation here, is the same as the mean. So we would do that, we would find the mean by multiplying these together. So we would have 1 multiplied by 0.23 plus 2 multiplied by 0.38 plus 3 multiplied by that plus 4 plus 5 and so on. So we would multiply all those things together and add them up. Okay? So we would expect, or we would expect that 2.39 would be the number of magazines that people would buy. And it's the same as it would be with the mean. Okay? Yeah? So we just multiply these together. And that actually gives you the value of the mean, which is the same as our expectation. Or our expected value. Now, fair games. Okay, this has come up a couple of times recently, and in gambling, we say the expected gain of a player is the expected return from the game less the amount it costs to play it. Okay, so how much money are you going to get back? Take away how much did it cost you to actually play the game. Okay, so that makes sense. Now, if the expected gain is 0, it means that the game is classed as fair. Okay? So if you find that the expected value is 0, you can say that the situation is fair. So here we go. In a game of chance, player spins a square spinner labelled 1, 2, 3, and 4. The player wins the amount of money shown in the table alongside, depending on which number comes up. Determine the expected return for one spin of the spinner. Now, at the moment, this table here, whilst it's a table, there's no probabilities in this table. So we have to determine what those probabilities are. So you've got a square spinner with numbers 1, 2, 3, and 4. What's the probability of getting a 1? 1. Nice. And obviously, it's the same for all, yeah? So that's our first thing. So for this particular question, they didn't have those probabilities there, but it was very easy to work them out. So the expected return for one spinner is going to be these things multiplied together. Now we're looking for the return. So we're actually not looking at the spinner number multiplied by the probability, but the winnings multiplied by the probability. Yeah, you're happy with that? So we would do 1 multiplied by 1/4, plus 2 multiplied by 1/4, plus 5 multiplied by 1/4, plus 8 multiplied by 1/4. Trace the others? And that works out here. We've got 1/4 plus 2/4 plus 5/4. Brother gives you $4 apparently. Okay. Now we need to find the expected gain of the game. Now it says it costs $5 to play the game. So what we said was to find the gain, it's going to be the return subtract the cost. So what was, our expected return? $4. What was the cost? $5. So we're going to do 4 subtract 5. Hopefully not too challenging. We get -1. So this game here, it averages out that we're losing $1 each time we play it. Yeah. And then part C had said whether, and then part C they said whether you would recommend playing this game. Well, are you going to tell someone to play a game that you're averaging losing $1 each time? No. So even if you happen to win, on the whole, this game is not fair because the expected value is at 0. Does that make sense? Yeah. That's it. Oh no, that's not it actually. So in that the big pack I gave you the other day, there was one other bit about variance. Let me pause this. So if they start talking about variance and stuff, you actually get given a formula. It looks similar to, it doesn't look quite like this. It says n p minus 1. But that's what this says here. So it says the variance is n, which was the number of trials, multiplied by the probability, multiplied by the not probability, essentially. Yeah, okay, so this is it. This is given to you. So, probably easier just to look through an example. Okay, so in a large company, 40% of the workers travel to work on public transport. A random sample of 15 workers is selected. Find the expected number of workers in this sample that travel to work on public transport and the standard deviation. Okay, so 15 workers, 40% travel on public transport, so the expected value is going to be 15 multiplied by 0.4. Yes? That's straightforward. So there's going to be 6 people. Now, they've asked us about standard deviation. This is where you have to remember conversations that we have when we're doing statistics. Do we remember the relationship between standard deviation and variance?
They're opposites?
Not opposites.
They are variance and standard deviation.
Oh,
What's
that
that
variance? Is that you just said?
Variance and standard deviation.
Yeah, so the variance of something is the standard deviation squared. So if we can work out the variance of something, we would square root it to find the standard deviation. Okay? Which is where they're a bit sneaky sometimes, because they're not going to necessarily say find the variance, or now find the standard deviation. They just talk about standard deviation. And if you're looking at something thinking, well, I don't know how to find that. All I know is how to find the variance, then it's hard to sometimes link those two together. So variance is then the number of trials, so that was 15 again, multiplied by the probability, which is 0.4, multiplied by the not probability, which is obviously 0.6, and you get 3.6. And then you just square root that. So that would be 1.9, which is standard deviation. So that was just one extra thing. The tricky thing is it gets to this point in the game and that some of this may never actually come up in your exam. They may just focus on some other questions. But it's the little bits that make things a little bit more tricky at this point. Okay, so we'll spend this lesson working on any probability questions you want to, whether it's binomial distribution or the original probabilities. And the next lesson we'll do stuff vectors. I just stopped thinking now, so I'm just looking.